Question 7. Find the first 4 terms in ascending powers of x of the binomial expansion of the square root of 4 minus 9x, writing each term in its simplest form. Okay, so firstly, this is a binomial expansion. We do have the binomial expansion included in our formula book. We have it in the form of 1 plus x to the power n, which is equal to the following for a modulus of x less than 1, and n being a real number. Now we want the first 4 terms. Now with a polynomial, which we're going to be forming, our 4th term would be to the power x cubed. So our first term is numerical. So if you think of a polynomial, a plus bx plus cx squared plus dx cubed, this would be our first 4 terms. So we have the square root of 4 minus 9x. Now currently this is not in the form of 1 plus x to the power n. So we need to look at how we can rewrite this. Well, hopefully we know that something square rooted is the same as being risen to the power of a half. So we can say that the square root of 4 minus 9x is equivalent to 4 minus 9x to the power of a half. We need 1 plus x to the power n. So we need to take a factor of 4 out from this bracket. Now when we take out a factor of 4, this 4 is also risen to the power of a half. It can often be confusing as to why this is the case. But if you imagine if you weren't raising it to the power of a half and you were just taking a factor of 4 out of the bracket, you would be pretty happy that you've got 4 lots of 1 minus 9 over 4x. All of that is actually to the power of a half. We can see from here that both terms, the 4 and the 1 minus 9 over 4x, both need to be risen to the half. Hence this line. The square root of 4 then is 2, and so we can rewrite this as 2 lots of 1 minus 9 over 4x to the power of a half. So now we're in a form where we can use our extract from the formula booklet. We have 1, our plus x is our negative 9 quarter x, and our n is a half. And so we can substitute these values into our equation for the binomial expansion. Substituting the values in, the point you need to be careful with is the x value. Notice we have an x on its own, but we also have x squared, and we will have, of course, x cubed. Remember that your x is the negative 9 quarter x. You'll see in brackets here, so it's the negative of 9 quarter x, which is all squared. The negative of 9 quarter x, which is all cubed. It's important we make these correct substitutions. Using your calculator or otherwise, we can simplify each of these terms to give us 1 minus 9 over 8x minus 81 over 128x squared minus 729 over 1024 x cubed. Now we can multiply it all through by 2, and this gives us our binomial expansion of the first 4 terms. So we've got 2 minus 9 quarter x minus 81 over 64x squared minus 729 over 512 x cubed. A student uses this expansion with x is equal to a ninth to find an approximation for root 3. Using the answer to part A and without doing any calculations, state whether this approximation will be an overestimate or an underestimate of root 3, giving a brief reason for your answer. So using this expansion to find an approximation, we would substitute 1/9 in for x. So 2 minus 9 quarters times a ninth minus 81/64 ninth squared, and so on. Now, with our first 4 terms, we would get a value. If we were to get a closer approximation, we would introduce more terms. So we would also have the x to the 4th term, the x to the 5th term, the x to the 6th term. The more terms we include, the more accurate we become. However, if we look, each term is negative. So we would be subtracting another value if we had x to the 4, subtracting again x to the 5. And so stopping after the first 4 terms will make our approximation an overestimate, as the following terms would be negative.